Hello everyone. I am Utkarsh Agrawal, currently pursuing second year of Masters in Construction Engineering and Management from SEPT University. My student code is PCM23414. I will be showcasing my third semester portfolio work for integrated construction practices studied under the guidance of Dr. Jyoti Trivedi, Mr. Paramjit Lota, Dr. Bhargav Dave, Ms. Sanjana Megwani, along with teaching associate Bhava Patel and Disha Patil. The studio had specified detailed deliverables focused on implementation of BIM, for which we visited a live construction site and conducted analysis after the information and inputs gathered from the interviews of the various industry experts and key stakeholders and came up with ways to improve project efficiency. The studio exercise includes BIM execution plan, defining level of development and level of schedule for the 3D models development, blast detection, quantity takeoff, site layout optimization, 4D and 5D simulation, and exploration of various lean construction tools like last planner system. As part of the studio, our roles are divided, and I will present you part of my study, that is 3D models developed, BOQ comparison after quantity takeoff, site layout optimization, 4D and 5D simulation, and comparison of traditional approach followed by the PPC track for my role. Starting with the project brief, the project taken up for this study is a commercial project. The project, with its distinctive charm and design, is being developed with the objective of establishing it as a coveted business space in the Ahmedabad city for both showroom and office spaces. The total site area is 6,140 square meters and the total built up area is 43,715 square meters. The estimated construction cost of this project is 94.1 crores. The total height of the project is 45.175 meter above ground. The project has three basements, ground floor followed by 10 floors. Up to the third floor is provided for showroom spaces, height 4.54 meter for each floor. As part of the studio scope of work, among the corporate tower and commercial building, we have taken up the commercial building and the area taken for the preparation of LOD 350 architecture and structure models. We have considered three basements and ground floor. And for LOD 400 blast detection and LOD 300 surfaces modeling, we have considered the ground floor. The requirements of the developer from the execution of BIM are visualization of massive floor heights, visualization of facade architecture elements, clash detection among various disciplines involved, site logistic layout, visualization and optimization, progress tracking using lean approach, 4D and 5D simulation to visualize construction process and cost. As part of the studio, I performed the role of contractor, plumbing and firefighting consultant. And the responsibilities as part of my role were developing a LOD 300 plumbing model, developing a LOD 300 firefighting model, quantity takeoff, site layout optimization, 4D simulation, cost estimation, and 5D simulation. These are the schematic and rendered view of the firefighting 3D model developed, and we modeled the pipes and firefighting accessories as part of our scope of work. The process followed for modeling includes importing levels and grids, followed by importing the 2D plan in Revit, and further modeling as per the model element author. Some of the constraints faced during the modeling process includes lack of prior experience of 3D modeling, absence of section drawings, and inability to understand the joineries increase the delay in the modeling. These are the schematic and rendered view of the plumbing 3D model developed, and we modeled the pipes, plumbing fixtures, plumbing accessories as part of our scope of work. Some of the constraints faced during the modeling process includes lack of prior experience, unfamiliarity with the software, unclear details in 2D drawings, absence of section drawings, missing plumbing fixtures specification in drawing. This graph shows that the cost comparison of the various elements after the quantity takeoff is done using manual and Revit quantity takeoff. The major variation is marked in red and is because of the variation in quantity takeoff. We can also see the exemplar BOQ prepared for AEC block. This shows that Revit enables precise cost estimation for complex architectural elements such as mullions and columns during the design phase, offering a clearer understanding of the actual project cost early on. The errors cause variation in quantities, which reflect in RA bills as extra items, leading to cost and time overruns. Time is lost in identifying, rectifying, and billing for extra items, causing delays in payments and project timelines. The time comparison of the two different approaches shows that the traditional approach requires additional 75 hours for the same scope of work. This is the existing site layout with all the components marked along with it. The rendered view of curing tank, contractor office, and client office are also showcased here. By studying and analyzing this, some of the critics identified are inadequate storage for reinforcement bars, unsegregated vehicular and pedestrian movement paths, no provision for dedicated scrapyard, no barricading around excavated area, inappropriate assembly point, and absence of medical or EHS room. For the proposed site layout, the critics were resolved and also POT analysis or path of travel analysis was done. For the analysis, the distance of the construction site from each considered parameter has been taken from the center, considering the fact that the manpower would be working anywhere on the entire floor, so that the center point would give the average distance of travel to the destination. The speed of 1.33 meter per second has been considered for calculating the time of travel. The site layout is optimized by shifting the steel yard to a new location, giving more area for cutting, bending, and storage of steel with proper segregation. The location of the client store, curing tank, security cabin, and labor colony was also shifted for the easy access of the vehicles to the site. Instead, from inside the labor colony with a common pedestrian path, EHS room, blockwork storage, and a dedicated area for scrapyard is also proposed. In POT analysis, the comparison shows that by optimizing the layout, we can reduce the overall manpower movement time by 32%, and it will eventually increase the productivity of all the laborers and site officials. The cost of optimization for each component was also calculated, and it was observed with a huge cost is associated with shifting of client store and curing tank, as they are masonry structure, and demolishing and reconstruction of the same increases this cost. And also a major cost is associated with shifting and enhancing the steel yard. The shifting and proposal of temporary structures is very minimalistic and with comparison of the permanent structure. For 4D simulation, a 6-week locate plan was created and tracked using last planet system. The scope of work can be seen in the top right corner using the Navisworks and Synchro Pro software. First, the construction sequencing was done, and further, after the tracking in Synchro Pro, the comparison of plan versus actual was done, and it was observed that in the first week, all the activities were as per plan schedule, but in week 2, there was a query strike which caused delays in the concreting activities planned, but no delays more than 2 days has been observed. Using Navisworks, a challenge was also resolved, which is multiple activities occurring simultaneously across floors. And the solution was by integrating the schedule with the 3D model in a 4D simulation, the contractor can visualize multiple construction tasks happening simultaneously on different floors and within the same floor. The QR can be scanned to see the various simulations. For 5D simulation, the cost estimation for the various activities was done and added in Synchro Pro for earned value analysis. The assumptions considered were productivity from site has been taken separately for reinforcement, shuttering, and concreting activity. The number of laborers were calculated based on the productivity, vertical and horizontal elements differently. Only labor cost has been considered as extra for delay activities, and the cost of materials has been taken as the same which were used for preparation of BOQ in quantity takeoff. The variance analysis shows that there was no delay on second floor, pore 2, but due to delay in third floor, pore 1, the future activities were also consecutively delayed, increasing the overall cost variance significantly. As the scope of work was completed within the stipulated time frame, the earned value is same as the budgeted cost, and further the SPI is 1. And due to minor delay and increased labor cost, the cost variance is minus 68,800 and CPI is 0.998. The QR can be scanned to see the simulations. For the comparison of traditional versus ICP approaches as part of this study in quantity takeoff through traditional approach, it is observed that manual quantity takeoff from 2D drawings are prone to errors impacting budget accuracy. But in ICP approach, automated quantity takeoff from BIM models ensure precise quantities leading to more accurate BOQs and efficient cost management. 4D and 5D simulation through traditional approach, it is observed that construction sequences are manually planned and may not align with actual conditions, leading to inefficiencies. But in ICP approach, 4D BIM allows visual scheduling, while 5D BIM integrates cost with time, enhancing visualization of project phases and cost. Site layout optimization. Through traditional approach, it is observed that limited planning leads to inefficient site usage, affecting safety and productivity. But in ICP approach, BIM integrated site layout and real-time tracking improve resource allocation, safety, and workflow efficiency. Further, in constraint mapping and PPC calculation in last planner system of contractor, it is observed that in week 12, 50% PPC is there due to unavailability of model on time. But in week 14, contractor was not available, and the average PPC is 81% for the modeling process. And for plumbing and firefighting consultant, it is observed that in week 1 to 3 and week 8 to 11, there is good performance. But in week 5 and 6, it is reduced because in the 5th and 6th week, there was software incompetency and suspension of classes. The average PPC came out to be 90% for modeling process. For conclusion of this portfolio, from 3D modeling, we enhanced spatial understanding by developing detailed 3D models of plumbing and firefighting systems. From quantity takeoff, we developed skills in preparing BOQs based on model data, enhancing the reliability of cost projection. From site layout optimization, we enhanced site safety and spatial planning by using 3D layouts to manage safety zones, access path, and storage areas through BIM. From 4D simulation, we developed skills in creating 4D simulations by linking 3D models with schedules, improving construction sequencing, identifying conflicts, and enhancing communication with stakeholders. From 5D simulation, we gained expertise in linking cost data with model elements using 5D simulation and earned value analysis for real-time budget tracking, proactive cost management, and financial accuracy. From LPS implementation, we recognized the value of tracking PPC for team performance, evaluation, and role of data-driven decision making in improving schedule adherence and minimizing rework.